China has done the impossible. Built a railway that stretches across 13,000 kilometers, connecting the east and the west. Imagine a train starting in China, crossing deserts, mountains and cities, weaving through 9 countries and arriving in London or Madrid. This isn't just a railway, it's a modern engineering marvel and the longest freight route in the world. But how and why did China build this? What drives a project of this magnitude, and what does it mean for the future of global trade and power? Let's find out. Over 1,500 years ago, caravans carried silk, spices and porcelain across the treacherous Silk Road, a vast network spanning 6,400 kilometers. It wasn't just a trade route, it was a cultural superhighway linking Asia, the Middle East and Europe. Today, China is reviving this legacy, but not with camels, but with a $1 trillion megaproject known as the Belt and Road Initiative, BRI. Launched in 2013, this ambitious plan is reimagining global connectivity through railways, highways, ports, and even digital infrastructure. The BRI's railway network now connects European cities and Asian cities, including the record-breaking Yiwu-London and Yiwu-Madrid routes. These railways aren't just faster, they cost just a fifth of air freight and emit a fraction of the carbon. They symbolize China's vision to unite continents and reshape the global economy, just like the ancient Silk Road did. The China-Europe Railway Express isn't just one route. It's a massive network of corridors weaving through 2 continents, connecting over 217 cities across 25 European countries, with more than 50 cities in China. Over 73 freight trains operate daily, transporting a staggering 70% of Asia-Europe cargo. At the heart of this network is a system of 3 main corridors, each designed to serve different regions of China and Europe. The eastern route begins in China's coastal regions, exits through Inner Mongolia and passes through Russia, Belarus and Poland before reaching Europe. The central route links the manufacturing hubs in central and southern China, entering Europe through Mongolia and Russia. Then there's the western corridor, the key to connecting Europe with western China. This route crosses Kazakhstan, continues through Russia, Belarus and Poland, and then splits in 2 iconic journeys, one to London and another to Madrid. The Yiwu-London route spans 12,000 kilometers, making it the world's second longest railway line. This journey, completed in just 18 days, passes through Germany and Belgium, crosses France and enters the UK via the Channel Tunnel, finally ending in Barking, East London. The Yiwu-London Railway was officially inaugurated on January 1, 2017, making London the 15th European city to connect with China by rail. Its maiden journey carried 30 containers filled with various goods, ranging from textiles to electronics, showcasing the versatility of this trade route. Meanwhile, the Yiwu-Madrid route holds the title of the world's longest railway. Stretching 13,000 kilometers, it was inaugurated in 2014 and became a significant milestone for global trade. The route continues from Poland through France and into Spain, completing its journey in 21 days. This connection set a new benchmark for long-distance rail transportation and strengthened trade ties between China and southern Europe. With over 11,000 trains running annually, the network is a critical lifeline for global trade, handling everything from electronics and textiles to machinery and luxury goods. And China is not alone in using railways to transform trade. The Gulf Railway, for instance, is an ambitious project connecting 6 countries in the Arabian Peninsula. Curious to learn how it's shaping the region? Watch our video on the Gulf Railway project, an incredible story of ambition and connectivity. But of course, nothing is without its fair share of challenges. The logistics in particular are very complicated. Why? Well, you surely know what happens when you involve multiple countries in a project, especially when they have different railway gauges and infrastructure. But what exactly is a railway gauge? Simply put, it's the distance between the inner edges of the 2 rails on a track. Think of it like the width of a car's tyres. If the wheels don't match the road, the car won't run properly. For trains, this mismatch becomes a logistical headache when different countries use different gauges. In China and most of Western Europe, the tracks follow the standard gauge, measuring 1,435 millimeters. However, in Kazakhstan and other former Soviet states, the rails are set wider at 1,520 millimeters. To navigate this, trains must switch gauges twice along their journey. First at the Kazakhstan border, where the standard gauge transitions to the broader one, and again at the Belarus-Poland border, where it reverts back to the standard gauge for the European stretch. These transitions are achieved by transferring containers onto rail cars designed for the new gauge or through bogie exchanges. For trains, this process involves lifting the cars off their current bogies and placing them on new ones that match the track width. It's like a pit stop for trains, but on a massive scale. The project, however, relied heavily on existing infrastructure, minimizing the need for extensive new track construction. Instead, the focus was on solving logistical challenges and coordinating between the national railway systems of the 9 countries involved. The most significant efforts were directed toward creating the infrastructure to handle break-of-gauge transitions, those critical points where trains must adapt to different railway gauges. But what about the construction itself? Building a railway is far from simple. It begins with ground preparation, where the terrain is leveled, soil is stabilized, and drainage systems are installed to prevent water accumulation. A layer of crushed stone, known as ballast, is spread to absorb vibration and provide stability for the tracks. Steel rails and sleepers, the crossbeams that support them, are then installed, forming the backbone of the railway. Yet China makes building megaprojects seem as straightforward as building a house. One of their secrets lies in the advanced machinery they specifically create for these colossal undertakings. Take railways, for example. China employs cutting-edge machines designed to revolutionize the construction process, such as the SLJ 932 bridge builder, nicknamed the Iron Monster, a 640-ton behemoth capable of lifting and placing prefabricated track sections with incredible precision. It features 64 wheels across 4 sections and can even rotate sections up to 90 degrees, allowing for efficient track installation in challenging terrain. Compared to traditional crane-based methods, this machine drastically reduces the need for manual labor and accelerates construction timelines. When it comes to high-speed rail construction, China doesn't stop there. The Kunlun bridge girder is a critical player. This massive machine, weighing 967 metric tons and stretching 116 meters, was specifically designed to construct double L box girders for high-speed rail bridges. Double L box girders are special support structures used in railway and bridge construction. Imagine them as giant hollow beams, shaped like a pair of L's facing each other, forming a box. They are incredibly strong, but lightweight because of their hollow design. This machine represents the pinnacle of modern rail construction technology, enabling faster and safer bridge building processes. For laying the tracks themselves, the CYP 500 track layer played an essential role. This machine can lay approximately 2 kilometers of tracks per day, exceeding the standard daily progress of 1.5 kilometers. Its standardized operating procedures ensure exceptional accuracy, even under varying conditions. But building high-speed rail isn't always smooth. Take California's $100 billion high-speed rail project. It's a completely different story. Curious about the challenges and delays they faced? Check out our video diving into the ups and downs of this ambitious project. It's a stark contrast to China's efficiency. Another impressive feature is the infrastructure along the routes. The Yiwu-London connection, for instance, utilises the iconic Channel Tunnel, seamlessly linking the UK to mainland Europe. Special transloading facilities at gauge change points, like the Belarus-Poland border, allow for quick and efficient cargo transfers, keeping the freight moving without significant delays. Bridges, tunnels and ballastless tracks have been engineered using cutting-edge techniques to withstand the demands of high-speed, long-distance travel. Of course, such an ambitious project faces its share of challenges. Precise track alignment and levelling are crucial, particularly in areas with challenging terrain. Environmental concerns, including water pollution and habitat disruption, required innovative mitigation strategies. And the need to harmonise railway standards across 9 countries, each with its own regulations, languages and technical systems, demanded unprecedented levels of international cooperation and negotiation. But why was it built? That's an easy question to answer. Money and power. Yiwu is the world's largest wholesale market for small commodities, a place where billions of dollars worth of products are manufactured and traded every year. From toys and clothing to electronics and household items, Yiwu's factories produce over 50,000 types of goods. It's the backbone of global low-cost manufacturing. Yiwu's annual trade volume is around $85 billion, and its success depends on how fast these goods can get to markets. That's where the China-Europe Railway comes in. Shipping goods by sea takes 30 to 45 days, while the railway cuts that down to just 18 days. This faster delivery means businesses save money, customers get their products quicker, and Yiwu stays competitive in global trade. The railway's impact is huge. In 2023 alone, it carried over 1.9 million containers, moving everything from cars and machinery to food and household items. Since it started, it's transported goods worth $380 billion, and it's growing fast. Back in 2011, the system started with just a few trips, but by 2023, it handled over 17,000 trips a year, linking 223 cities across Asia and Europe. But money isn't the whole story. This railway is also about power. By connecting Yiwu to cities like London, Madrid and Hamburg, China is strengthening its influence in Europe. These connections aren't just about trade, they're about building relationships and showing that China can play a leading role in global logistics. Take the Yiwu-London route, for example. It gives China a direct link to the UK, which became even more important after Brexit, when the UK needed new trade connections outside the European Union. The Yiwu-Madrid route, the longest railway in the world at 13,000 kilometers, ties China to southern Europe, helping it extend its reach across the continent. This railway is a key part of China's Belt and Road Initiative, a global strategy to reshape trade routes. By connecting so many cities and making trade more efficient, the railway helps China strengthen its position as a global superpower. Today, the railway handles 70% of Asia-Europe cargo, showing just how vital it has become. China's Belt and Road Initiative is reshaping global trade, and the China-Europe Railway is a cornerstone of this transformation. It's not just a railway, it's a statement of China's ambitions, uniting continents, boosting trade, and extending its influence. With faster delivery times, lower costs, and a vast network of connections, it's clear why this project matters. But here's the big question. Is this railway just a tool for better trade, or is it part of a broader plan for global power? Let us know your thoughts in the comments below. And if you're curious about more megaproject stories, make sure to subscribe for more. Thank you for watching.